In this video, we're going to discuss the questions that are listed on the Ionic Compound Lab. So first off, in our data table, we were able to measure the mass of the empty, clean, and dry crucible with the lid, and then the mass of the crucible lid and magnesium. So later, at the very end of the lab, you measure the mass of the crucible lid and magnesium oxide product. So before moving on, what I want to explain is we started with a long strip of magnesium metal. If I was to zoom in on one piece of this strip, we would see magnesium atoms all packed tightly together, and every single one of them has 12 protons in the nucleus and 12 electrons arranged outside the nucleus. But that strip of magnesium was just one atom packed next to another atom, millions and billions of atoms packed together. The way that I know that it has 12 protons and 12 electrons is magnesium is number 12 on the periodic table. Since this is magnesium metal, there is only one type of atom, and we call it an element, and all those atoms are packed tightly together. What we have done when we heated up the magnesium, we allowed it to connect with oxygen atoms all around, at first, all around the surface of the magnesium. So these oxygen atoms come in from the air and they connect to the magnesium. This is why when we first started, the magnesium we saw as a silver color because it was atoms of magnesium. And then later during the lab, we saw this substance is a metal atom, magnesium, connected to a non-metal atom, magnesium. So we call it magnesium oxide. And I think that you were able to see that later, once we opened the crucible, removed the crucible lid, you were able to see a white crystal structure. That white crystal is an ionic compound. So we started with just simply a metal atom, and we allowed it to react with a nonmetal, oxygen. And when we get a metal connected to a nonmetal, it forms an ionic compound. Now, magnesium in column 2A wants to become a 2 plus. Oxygen in column 6A wants to become a 2 minus. So it just becomes 1 Mg for every single O. So they are connected, an Mg and an O, an Mg and an O, an Mg and an O. So unlike this ionic crystal, which has 2 ions per every other ion, so maybe this could be CaCl2, where Ca is in the middle, and 2 Cls, 1 Ca, 2 Cls, 1 Ca, 2 Cls. This is actually a 1-to-1 ratio. So it'd be the same crystal structure, but it'd be a 1-to-1 ratio instead of a 2-to-1 ratio. So at the end, what you measured was the crucible, the lid, and the magnesium oxide product. That is your product. That's what you end up with at the end. So when you're finding your magnesium metal, the amount of magnesium metal, you're just subtracting these two. You're subtracting your crucible with your lid and your crucible with your lid and your magnesium, because when you subtract those two, what you will be left with is just the magnesium. Then down here, to find the magnesium oxide, you're going to then subtract the clean, dry crucible with the magnesium oxide product. You subtract those two to find this one here. So that will allow you to know what your mass was that you started with, only the magnesium metal, and now your mass of your final product, your original magnesium. Notice, the original magnesium atoms didn't go away, they're still there. You can think of them almost as coated or surrounded by oxygen atoms. Then we kind of broke it up, and then those inner magnesium would have a chance to connect with the oxygen as well. So then it asks, compare the mass of the magnesium metal with the mass of the magnesium oxide. Well, our magnesium oxide should have more mass than the magnesium metal because the magnesium metal only contained the magnesium atoms. And now the magnesium oxide product includes those original magnesium atoms plus the oxygen atoms that are now connected. So we should see the magnesium oxide has a larger mass than magnesium. And the reason being is we've added those oxygen atoms connected to those magnesium atoms. Then, here, we check the conductivity. We should have found probably between 10 and 15 blinks, and probably maybe 1 to 2 blinks. What this means is it is conductive for the magnesium oxide, but distilled water is non-conductive. Here's what we are checking with conductivity. So conductive indicates ions are in the water. Non-conductive indicates no ions are in the water, or very little ions are in the water. So here's what happens when we place an ionic compound into water. Here is our example of our ionic compound. And when we place it into water, what happens is, in the next unit, we'll find out that water is attracted to the positive and negative ions. So the water comes in and starts to pull and tug on the ions until it pulls it away. And another water comes in the opposite direction, and it pulls and tugs on the positive ion and gets pulled away, or in this case the negative ion, and it gets pulled away. So what happens are these ions get pulled away from their crystal structure, and they end up floating around individually among the water molecules. That process is called dissolving. That process of pulling apart the individual ionic crystal structure into its individual ions, that is called dissolving. And because this ionic compound dissolved in water, now there are ions, individual ions floating around in the water, and that causes the water to be conductive. This is why the distilled water showed non-conductive, because there aren't any ions in there. So what we showed by finding that placing magnesium oxide into water and seeing all of those blinks that we got, and it being conductive, what we've shown by it being conductive is the substance that we placed in water must be an ionic compound. So it's evidence to us that that original magnesium metal connected with or stuck together with or bonded with the oxygen in order to form a white crystal, and that white crystal is an ionic compound. When that ionic compound is placed in water, it dissolves. What does that mean? It means that it separates into its individual ions. Since there are ions inside of that water, it is conductive. So that is the second piece of answering the questions for the activity. And then finally, for the final page, I'd like you to include a discussion of the process that takes place when magnesium, that is a metal, reacts with oxygen, that's a non-metal, to produce an ionic compound called magnesium oxide. Include the process that takes place when the magnesium oxide is placed in distilled water. We know that it dissolves. The ions are separated from one another. Include the types of ions that exist. Well, when this gets separated, it gets separated into its magnesium ion and its oxide ion. So in that water, you'll have millions and billions of those individual ions floating around. And then make sure that we include these words in our description: ionic compound, ionic bonds, metals and nonmetals. From our chemical bond chart, we know there's a big difference in electronegativity between a metal and a nonmetal. A metal has a high electronegativity. A nonmetal has a high electronegativity. A metal has a low electronegativity. Because of that difference, an electron moves, or more than one electron moves from the metal to the nonmetal. There is a transfer of electrons based off of that electronegativity difference. The final substance is an ionic crystal. The smallest unit we call a formula unit. We talked about dissolving up here, separating into its individual ions. And we talked about how water is attracted to those ions, and that's what pulls the ions apart. I hope this helps in finishing up the final 2 pages of our ionic compound lab.